Hi, my name is David Torres. In this video, I will show you how to set up tripwires with Honeypot. We will start talking about what is Honeypot. Then I will walk through the installation and the code of each module of Honeypot. And finally, I will install and test it in a demo. Honeypot is a laser-focused modular honeypot. It is free, Libre, and open source, available in GitHub. Note, it is not meant for cybersecurity researching where they are publicly exposed. What I mean by laser focused and modular is that you can just enable the module equivalent to the service you want to mimic in the honeypot. Then it will send you a notification via email telling you that the wire was stripped. The quality of the information in the notification depends on what the honeypot can provide, but how segmented and isolated environments are. The TCP module can listen on any port, in multiple ports, or in a range of ports. It automatically accepts and drops the inbound connection immediately, which makes it trip even with half-open scanning in the TCP handshake. The FTP module listens on only one port and it will pretend to be one FTP server. It will log credentials and send them inside the notification. This might reveal that a credential for a user account or a service account have been compromised, or at least give some idea of what is being used as payloads to brute force into the service. Similarly, the HTTP module pretends to be one HTTP server with basic auth, and it logs the credentials and also sends them in the notification. The DNS module is the only module that listens on UDP, port 53, which is the default for DNS. It logs and reports what are the domains trying to be resolved in case there is one threat actor or malicious application trying to enumerate what are the assets in that segment of the network. And finally, we have one email notification module that looks for the flags created by the other modules and sends the email notification. This project started about 2 years ago, when there was a need for a solution with a very small footprint to run inside a Linode or a DigitalOcean single core instance or in a Raspberry Pi, for example. And since then, it is being used in real production environments where I allow it to be triggered every time our vulnerability scan runs. So I know that the vulnerability scan did effectively started. I know that my tripwire is active and working, and the payload reveals where it's coming from, which is my vulnerability scan that's scheduled to run every week. As a recommendation, I would run one instance of the Honeypot in each environment or each segment of the network. In fact, each instance of the Honeypot consumes close to nothing of resources because it stays idle most of the time. And it's capable of running in any architecture, ARM, x86 or 32 bits or RISC-V, as long as there is Python libraries available for it. Let's take a look into the code. In this repo, we can see, of course, license and README. We have deploy. Deploy is one installation script that will simply ask for the information for SMTP, the credentials and everything, and you set up a service using systemd. Then I have here DNS module, FTP module. HTTP model and TCP model. These are just illustrations. This is the shell script, the bash script that executes the Python. And what it does is it receives one argument and then it knows what is the module it has to start. This is the email notification module. I call it snitch, which because why not? That's what it does. Then the template for the service and the trigger. The trigger is a tester that we can execute just so we see it triggers all the modules at once and we confirm everything is working. The README starts explaining what it is, what it does, where it can be installed, locations and how it may work, the description of each of the modules I explained in the slides, and gives short copy-paste commands for installing, which is pretty much switch to use the root account, clone the repo, and execute the installation script called deploy.shell. Let's see how the deployment works. So these are just colorful boxes to look cool. It asks for the information to connect to the SMTP server, the information for the email, sender and destination, and then it asks for each of the modules, yes or no, yes or no. So to install the TCP module, just type Y and enter, and then it will ask for the FTP, Y and enter, and then it's going to install one by one. What it does is it gets the template that we are going to see in a bit for the service using systemd. We replace the variables and we'll place it in the appropriate location. So systemd will find it when we reload all the 5 modules, 5 Ys if you want, all of them. Then it reloads all the services and gives you like a cheat sheet. You can just copy paste and start the service that you want to. I would recommend to also start and enable so it starts automatically on the boot. So the template for the service looks like this. Simply waits for network, has all the environments for connecting to the SMTP server to send the emails, then always restart, delay of 2 seconds. This is the working directory, and this is the shell script that will execute the modules, and it receives a parameter, which is actually the name of the module. This is how it can be found in the syslogs. Honeypot will be identified this way. So let's look at the Honeypot shell. As I mentioned, this script name is the parameter. So the module will be here, the Python module will be loaded, and it will log in the same location, same directory, the working directory. And this honeypot.log file works as an inter-process communication file. So all the modules will save their logs in the same location where the snitch will finally open and find them and send the email notification reports. Let me jump straight to the email notification, the snitch script. It starts loading the libraries, the dependencies. Then I will jump this function here because it will be called later. I explain it. It is one infinite loop, and it reads that inter-process communication file with all the logs for those modules that were triggered. It loads everything into lines, wipes the file, then it breaks down line by line because each trigger in each module generates one line event. It parses those. What it does, pretty much, it looks for whenever there is username, field, which comes from FTP and HTTP. When it has domain, because it is related to the DNS, then it does some counters. And whenever it finds listening. Listening means when the module is started, the service is started, it says started listening on port, whatever. The purpose of this is that we can see the health of the application. If the application is crashing and is always restarting, whatever is happening over there, we see that it starts over and over and over. This is also a good information if this server is restarted, rebooted. As they start again, all the services come back up and you receive one email saying all of these modules were started, they're listening on ports, whatever ports. Then looping through the lines, each line means one event, so it starts doing the counters, some metrics, and sends the report. The send report function gets the environment variables that are passed from the service, from systemd, compile the report into email format, and sends it, pretty much. And then because it's one infinite loop, it waits for 10 minutes to check the log file again. 10 minutes is one arbitrary number that works for me. 1 to 5 minutes, I think it's too frequent. Over 30, 1 hour, it's too long time in between checks. I think it's not worth the threat actor, or the source of the request might not be easy to find 1 hour after the event. Let's check the DNS module. It creates a socket, listen on all interfaces on port UDP 53, the default. Then it keeps always listening, one infinite looping, listening for data in that socket. It tries to identify what is the IP that the source is requesting the resolution. If the domain is not to be found in the request, if it's not to be found, we understand it is just a port scan that trip the honeypot. This is just one arbitrary number, not really necessary, but I craft quick and dirty response with that IP 1234, pick yours, and respond to the requester. The FTP module, listen on all interfaces, TCP21, default port for FTP, opens a socket. When it starts the service, it always says listening on and prints. So we get one report saying that the service is started. It listens on the socket. When there is one inbound connection, it responds with the status code 220 and pretends to be VSFTPD, this version. And right after, it also asks for the credentials and pretend that the credentials did not match, but actually it's just logging them. If no credential was passed, it was maybe a failed tentative with no credentials, or even a port scan. Then the HTTP module, very similar, all interfaces, port 80. In this case, I have to use base64 because library, because the basic auth comes in base64 encoding. Does exactly the same, pretends to be, and then a service, and then says, oh, you are not authorized, please give me credentials. It also logs the credentials and then continue to say, no, didn't authorize, your credentials don't match. And that's pretty much what it does. Let's see the last module, TCP. This process has multi-threading. Each port it's listening on is a different thread, a child subprocess, let's call it this way. Listen on all interfaces and a list of ports. This is a single port. This would be a list of non-sequential ports. This example has two, but could be as many as you need. And a range of ports is I don't know, in this case from 8080 to 8090. Why not? Then I will skip this function for a bit. Let's go in here. This is the main function. It checks how many ports are in the ports array, and per port it starts a different thread, and all the threads are tracked until they all finish together. It's just a way of keeping all the threads alive at the same time. So each thread will be executing the listener. Then this function will use the socket to listen on the IP and port, and will log that it started, and it doesn't pretend to be anything at all. It just identified that when ACT package was received, it immediately rejected. That's what it does. This makes it capable of identifying when it's being scanned with half open handshake for stealth port scans. Then it will log the event. So in summary, this honeypot is just a super ultra simplified, quick and dirty way of identifying that something is going on in some segment of a network when events trip specific modules, all the 5 modules. These 4 grab as much information as necessary. The TCP doesn't grab anything other than what was the source of the request. HTTP and FTP, they try to make the source reveal some credential, might be indicative of exposed and leaked credentials, real credentials from the organization, or maybe just random brute force ones. The DNS will reveal what the threat actor or malicious application is trying to enumerate. They will all 4 save into the log file, which is a kind of inter-process communication file, where the snitch, the email notification module, will find it, sort, and create a report and send via email. So I deployed a temporary server and installed Git, so I could go to the directory, clone the repo using Git, and getting into the directory of the repo, listing the files. This is the clone of the repo. Now we are ready to execute this script. The deploy script is one installation script. I will not enter any real information here, but we'll show you how it works. Yeah, it's for confirmation. Then sender would be and the destination would be something like this. Yes. TCP module, FTP module. Let's do for HTTP, DNS, and this niche. All services were created. I can start this service. I could also enable it to start on boot. Let me start them. Accept this niche. I will not receive any email during this test because what I want is to look in this file. So all 4 services were started. So let me start a connection on that port for the TCP module. 2049. Yeah. And for example, for FTP, yeah. Let me try to connect to the FTP and give some credentials like username, yeah, username, strong password. Let me do dig google.com add this server. Yeah, it knows it's resolving. Let me use Nmap to trigger port 53 for the DNS. So when I use dig, I really resolved and I got 1 IP back. But now it knows I'm not really resolving. I'm using some sort of port scan and I tripped and it knows it's a port scan. Let me use curl and trigger the HTTP user name. Strong password. Yep, all there. In this case, I will leave with you to test this niche module with real credentials and get the reports in your real email.